Okay, let's take a look at example 1 of area 12 of the Passport to Advanced Math. Here, the area 12 generally deals with nonlinear expressions, nonlinear equations, and this is a typical example of a nonlinear equation. In this particular case, you are dealing with a quadratic model because your variable t is raised to the power 2. We know if you are dealing with linear system, then your y will be equal to mx plus c or b. This is the general model that we use for a linear system. As you move into the nonlinear system, then it just get out of this range and it become y is equal to ab to the power x is a nonlinear system, in this case an exponential system, or my y is equal to e to the power x, y is equal to 3x cubed minus 2x squared minus 1. These are all nonlinear system. Okay, so you generally be seeing things like that. Not difficult, but they expect you to make some decision on the expression that they give you. In this case, they gave you this expression, and they are asking this boy is sitting on the 25th floor of an apartment building, throws a ball at 20 feet per second to hit the ground, and they want to find out how high the ball is from the ground. So let's take a look at this. So the boy is sitting somewhere here. This is, we have apartment. This is an apartment building. So the boy is sitting somewhere here. We have this apartment somewhere here. And the boy is sitting somewhere on the 25th floor. And decide to drop the ball, and the ball is going to drop like this. All right? Going to drop like this, taking a quadratic form like this, and then hit the ground. All right? So the ball hit the ground as a point here. Does that mean the distance from where the ball is to the ground here up to this point here is some distance h, and that h is modeled by this equation right here. All right, the question is, what is the boy's height, the height of the boy from the ground? And that will be this distance right here, right here. Right, how do you calculate that? Well, we know for sure that before the ball is dropped, the ball is not going anywhere, and so at the time when t is equal to 0, the ball is sitting right here. That means if you plug in t is equal to 0 in this equation, h is equal to minus 5 0 squared plus 20 0 plus 150, and that will give us 150. That will give us the distance where the ball is. And so generally speaking, which means your answer is D in this particular case, but generally speaking, when you see the systems of equation, it's no different from the linear equation. If you are lucky to have it in this structure, most of the time for quadratic function, you may also find the point where the curve cuts the y-axis, which will be the point where x is equal to 0. So you can either plug it in or you can visually see it. Like in this particular case, the constant term here, at times you may see the word starting point, initial point, fixed point, all are buzzwords that you can use to find the point when t is equal to 0, or at times when x is equal to 0 if x is the independent variable. So here, the boy's height is 150 feet from the ground, and that will be the height of the 25th floor of the building. And so these are very simple problems that you generally should be able to solve without any problem.